Hi, my name is Paul Tice. I'm with I-10 Associates, and today I'm going to be showcasing a project from the Evergreen Wings and Waves Water Park. This was a 5-story water park in McMinnville, Oregon, that we laser scanned over the period of a weekend. And from that, we created quite an interesting animation for the owner using solely the MicroStation environment. So this presentation I'm entitling is MicroStation Goes to Hollywood. For this project we used several software platforms, and I like to use many of them that are open source. We began with MicroStation V8i as our base platform to do all the major animations, the renderings, as well as all of the other components of the model that you'll be seeing later in this presentation. We use the Blender game engine, which is a great device to capture water, and you'll see how we did that in an animated way. We used Adobe Premiere, which is our movie-making software. However, you can use any kind of Windows media device or some basic movie-making platforms, because all we're really doing is taking image sequences and stringing them together. We use Corel Paint Shop Pro. This is a great program to create photo textures and to match the actual colors and some of the artifacts that are within the laser scans to the vector model. I used Virtual Dub primarily to break apart movie files that I was creating from the Blender game engine, and finally the Cam Studio Recorder, which is also open source. And if you'll see, there's a sort of pattern here with open source software. So this project had a very small budget initially and remained that way throughout the remainder of the project. So we decided to use some platforms that were available to us that are highly competitive, highly sophisticated, and have the ability to produce exactly what we want. And the great thing about MicroStation is its interoperability, so we can take multiple platforms and actually integrate them into that environment. The context of this project was to make a fly-through video to showcase this water park and to put that on our local news station and on their website as well. So we decided that laser scanning the entire thing and doing a fly-through would probably be the fastest way to get that to them, because we only had a 2-week deadline. So we went and scanned it for the weekend and came back and thought that everything was covered. What we did find, though, was there was a great deal of occlusions or blockages or obstructions for the line of sight of the laser scanner. And in that, we discovered that we had a lot of missing data. That was a problem for a fly-through video because we needed to have a comprehensive view of what was going on in the water park for showcasing it. We also had some problems with the lighting issues, so our camera exposure was a little overexposed in areas that were next to the windows. Because the whole water park is surrounded by windows, it's illuminated with natural light primarily during the day. Quite beautiful, but quite difficult for a laser scanner to have consistent lighting. And finally, we had asked the client if they could remove the chairs or not have chairs in the water park when we did the scanning to reduce the amount of occlusions in that way. And unfortunately, when we arrived on site, the chairs and the tables for the guests that would be coming and eating lunches there with their children and so forth, the chairs were already in place, and there was literally hundreds of them, so it wasn't practical for us to move those. So we went ahead with the scanning anyway. What you see here is our mess, as I like to call it. This is the water park and about 5 or 6 scans that have been turned on, and as you can see on the floor, there is a great deal of occlusions, there's a great deal of missing data. So the blue background indicates areas in MicroStation where there's no point cloud data, and all the color, of course, is the point cloud data with absolutely no vector geometry in place at this point. The solution to this problem was to create a hybrid model. This model was created from the point clouds. It's of surfaces and solids within the MicroStation environment, and you can see how we photo match the textures to the actual laser scans. Within this model, we can also see a B-spline surface where the pool is. And the B-spline surface is a great tool for keyframe animation, so I was able to create a wave effect in that during this process. And above on the ceiling, you can see what looks like flashlights. That's the lighting that I've used to illuminate some of these surfaces to match what the point cloud looks like. And the final result, the hybrid model and the point cloud superimposed upon one another. So as you can see, the occlusions have been filled, and when we apply things like motion blur and some other effects in the animation taskbar within MicroStation, a lot of the occlusions that still exist become somewhat invisible, as will be shown later in this presentation. The illusion that we created with this fly-through video I like to call the trompe-l'oeil of point clouds. In other words, we're taking something that is not complete and giving it the illusion that it is complete. And as this goes along, I'll be showing you some of the tips and tricks that we use to do just that. Before we began to do any hybrid modeling with surfaces and solids within the MicroStation environment, we chose a rather rapid way to fill in occlusions, in this case with the interior fuselage of the 747 that sits on top of the water park. As an aside note, the 747 was lifted onto this building and permanently decommissioned to be a part of this water park. So what happens is the kids run up these stairs, about 5 flights of these stairs. They get into the interior of the plane, and in the plane there are water tubes that lead outside of the building and into the pools within the interior of the building. So they jump into these slides and have a great time going down those. Well, inside of the fuselage there was occlusions as well. The scanner could not pick up everything within that because there's just so many different blockages of line of sight. By using a background that comes stock with MicroStation, in this case a sort of sunset background, we were able to cover up those deformities or those missing areas with just color, and that gave the illusion that we actually captured everything. Here's another view of the 747 point cloud with surface models on the side that look like glass. The opacity of those surfaces is set to such that make them look like they're translucent and somewhat darkened, which is actually what the environment looks like there. You can also see the water tubes that have been modeled coming out of that. We didn't need to model the entire water tube. We just needed part of it to show that the kids would be sliding down that tube in an interactive way for this video. You can also see these long strips, which are actually B-spline surfaces set with opacity on those as well. And that will be the water, the illusion of water that's within the slides themselves, as you'll see in the video coming up a little bit later. The first major part of the hybrid modeling process involved extruding the walls from the cropped point cloud in gray, and the green blocks are solids that we use to penetrate the surfaces and to trim out the windows using the trim tool in the solids modeling taskbar. Because there were so many occlusions from the chairs and other obstacles within the water park, we had to completely recreate the floor to make that look like it was a solid. So the orange here is a large surface, and the yellow are vertical surfaces that we use like a cookie cutter to trace out the paths and to cut those pathways to indicate some sense of realism for the flooring. Using Corel Paint Shop Pro, we were able to take the photos from the laser scanner and crop them up into our own materials palette. Now, as an aside, our laser scanner is a Faro LS Photon, and on the top of it has an optional camera mounting system, which is a Nikon D300 with a fisheye lens at 10 millimeters. It takes very good photos as long as the exposure is set correctly and all of those things. And with this, we can create our own material library that we can also randomize using these types of software platforms. You can use Adobe Illustrator, you could use Corel Paint Shop, you could use GIMP, which is open source as well. Whatever your tool is that you decide to use, it is a good idea to create some level of blemishes on your materials in a random sort of way so that when you lay those down on a surface it doesn't look like a repeating pattern, which lends itself to losing realism. So in this way, we make the pattern look like it's actually a photo of the entire floor, when in actuality it's just one small part of it that's repeated several times. Next, we apply the materials to the surfaces within the 3D hybrid model. And these materials, again, were taken directly from our homemade palette. Another thing that we were able to do was to do a virtual walkthrough using the standard walk tools and fly tools within the MicroStation environment to go through the point cloud. So what we have is sort of a flight path within the point cloud, and along the way I would stop at certain vantage points and take a screen grab. So I was essentially taking pictures within the point cloud. Now, the way I can do that is MicroStation comes stock with the Vortex Point Tools rendering engine, which is a great photorealistic way to render point clouds. So as soon as I stop moving or orbiting within the point cloud, it renders itself within just a couple of seconds into a photorealistic visualization. And so from that, simply taking a screen capture is like taking photos within the point cloud. Well, this is a great thing to do for creating textures, because now I know that all my surface, vector surfaces and the materials on those is going to match exactly what the point cloud looks like. So I'm not going to have any kind of odd colors or spend all day trying to figure out what shade a certain blue is or something like this. So it's a very fast way to photo texture your hybrid model. Continuing with the modeling process, here we have a shot of the entire model in its partial completion. You can see on the rooftop would be the skylight with opacity set on those surface materials to make it look like windows. You can see the point cloud on the right-hand side of the screen that's sort of intermingled with the cloud, and you can see water down there as well, which is actually just a B-spline surface with animated textures flowing over the top of them. And I'll be talking later about how we created animated water within MicroStation. Finally, you can see this yellow spline that's sort of spaghetti weaving throughout this cloud, and that's one of the flight paths that we use to take the cameras on for the actual animation. And here's another angle of that 3D model as well. So you can see in the background the point cloud has some illumination on it, which was the actual lighting from the interior lights of the water park. And to create that lighting effect on the textures, I actually placed MicroStation lighting elements pointing down at a certain lumen rating that would illuminate those surfaces to give the illusion that the point cloud and the surfaces are all contiguous as one body. For the 747 model on top of the building, we actually used a model that was downloaded from the internet that we purchased. Because our timeline was so short, we didn't feel that we really could use our time effectively by creating the model from scratch in the MicroStation environment. So we went ahead and purchased a model from TurboSquid, which is an online resource, but there's also other online resources for 3D models that many people go ahead and download for free. They offer them for free. Modelers like to post them up on their websites just to showcase what their capabilities are, and there's a lot of reasons for that. So we went ahead and downloaded this, and you can see in the next slide the result of that when it's rendered. Fortunately, in the MicroStation environment, we have the ability to place textures on 3D models in any capacity that we like. So when we downloaded this 747, it came as just a gray model with decals or textures as a side palette, almost like stickers on a model airplane that come in a box. So I took those decals and I actually placed them on the mesh model of the plane and rotated them and scaled them into place. And then I rotated the entire plane and scaled it to fit the partial point cloud that we had for this 747. The scans didn't reach to the top of the plane, so using the scans alone for the visualization part of this video sequence wasn't going to work or look very good. So that's why we chose to use an actual 3D model that we downloaded from TurboSquid. The other thing that we did is rotated the landing gear outside of the aircraft because the model came with the landing gear retracted. So within this 3D model, there's actually a cargo bay inside, and you can kind of move different things around on the model. It's kind of interesting. They almost make it interactive when people do these really high-end 3D models. And fortunately, MicroStation can handle it. MicroStation can import all kinds of different files. This was actually an object file, and it was intended to be used in Studio Max, and MicroStation can read it just fine. At this point, the model was complete to our satisfaction, and we began to use flight lines to place the animated cameras on and point the cameras at various moving targets throughout the MicroStation environment to record our various sequences. Part of the project requirements was to capture the main features of the water park for at least 4 to 5 seconds per feature. So they wanted 5 seconds of animation on the wave pool, 5 seconds of animation on the largest water slide, and on it goes. So with this, we were able to determine various flight paths by simply moving B-spline curves around and running preliminary flight runs with maybe just one point cloud turned on at a time or just the vector model turned on at a time to be able to quickly visualize how this was going to look within the animation. I also changed out the lenses of the cameras, which is a great feature in MicroStation, so you can have a fisheye lens all the way down to a telescopic lens. And so for different angles, you're able to get different effects. You can have the camera roll along the B-splines, so the user or the viewer would see this animation kind of go upside down like you might be spinning in an airplane. Or you could have it actually just stay vertical and upright as it flies along the B-spline. And the other thing that you can do is have targets, which are little sphere objects that you can find on the animation taskbar. And those objects can be animated and keyframed and become little actors. So every animation component in MicroStation is called an actor. So a camera is an actor, a target is an actor, and so forth. And what that means is that you can animate actors and have them move in a particular way, parametrically, as it were. So you can have a camera follow a moving target while staying stationary, or have the camera be moving and the target be moving simultaneously. And so that way you can track different things that are happening within the animation. And in mid-sentence or in mid-script, you can have cameras change to different targets. So you can have it switch targets and have a different perspective. So it essentially becomes like you're the director of a movie and you have full control over what you're seeing at any given time. And all the lighting and everything is in your control as well. In this frame rate test, you'll be able to see here how the cameras are actually flying along the B-spline curves. And during this, you'll see the animated textures rolling along the water as well. And I'll talk about that more later. The reason I have this frame rate test in this slide is to show that we have the ability to actually control the speed at which the cameras go by how many frames you put in your animation producer dialog box. So if I put 100 frames, the animation will go very quickly. If I put 3,500 frames, which I did in this case, the animation will go much slower because it's creating more frames and it's going to take more time to move through those frames. So you control the speed at which your animation, or the speed at which your cameras fly through the animation rather, by the amount of frames you select for that particular animation. And here's an animation camera that's about ready to make the leap down the water slide. So what you don't see is a B-spline that is in the exact center of that water tube that we modeled, and this camera is attached to it. So I simply have the camera sliding down the B-spline and giving the effect that you're going through the water tube. As we watch this sequence, you'll see the plane looks like it's flying overhead, and actually what's happening is the plane is absolutely stationary, and I have a camera that's sliding on a spline underneath it to give the illusion that the airplane is in motion. I actually learned this trick from watching Star Wars multiple times and how they made those TIE fighters fly through asteroid fields. So we learn from what we experience. You'll also see how the water tube effect happens here as we get into the plane and shoot down the B-spline there. When creating the actual fly-through animation, I also was looking at ways that we could circumnavigate the cloud creatively so that we could actually create a good visualization that would omit occlusions and capture the hybrid model with the fullest part of the point cloud as possible. To do this, it was simply a process of having the B-splines adjusted from various directions, adjusting the camera angles, adjusting the way the targets were moving through the point cloud so that we could optimize the way the fly-through would look in the final rendering. Creating the water animations involved going into the Blender game engine, creating a normal map, and 2 cloud images that are different in size and different in color and texture, and having them sequence with each other and blend together. So I animate one cloud texture from one direction and one cloud texture from another direction, and when they come together over a normal map, they create this sort of ripple effect based on the lighting parameters in Blender. There's a tutorial on how to create animated water in Blender. It's actually pretty simple, and the neat thing about that is that we can record that animation and create a sequence of bitmap images which can be converted using Corel Paint Shop Pro or other batch processing software into JPEGs, which MicroStation accepts. And using the Animate Material Settings tools within the Animation taskbar in MicroStation, you can go ahead and take those sequences and do a pattern map increment. And what that allows us to do is take that series of animated sequences and place them on a surface and hit play, and the surface will look like it's actually having water rippling over the top of it. So it's a neat little trick to be able to bring in real-world sort of environments into your animation. This preliminary animation shows all of these elements in action without the point clouds turned on yet. We see the B-spline surface of the water and the textures flowing over the water, and we see the camera flying over the top of that, and then there's an animation going on the jumbo screen in the back with the same process I used for the water, showing the airplane flying through the air. As an aside, the way that we actually created the imagery on top of that moving water was to have a virtual camera walk through the point cloud, as I talked about earlier, in taking screenshots of different textures of the point cloud to match that to the vector model when we're creating those textures on the model. I simply took the camera and I pointed it straight up at the ceiling of the point cloud, or vertically, and took a screen grab of what the ceiling would look like. And then I took that image and placed it in a reverse way onto the B-spline surface of the pools so that you could have the effect of seeing a reflection on that water. MicroStation has the ability to produce AVI files as well, so one does not need to go directly into a movie maker to take a sequence of images to make an AVI file or an MP4 file or any other kind of movie file. You can do it directly in MicroStation. So in this sequence, this is the final sequence of the animation that we did for this particular project. And I wanted that plane scene flying through the sky and then kind of going into space, because it's a space themed water park. So they have astronauts pasted on the walls, and they have the Apollo 13 mock-up in there and stuff like that. So it's a really fun place. And so to showcase that plane flying through space was sort of a creative idea, and we wanted to put that on the jumbo screen in the animation. So the way I did that is I created an AVI file directly in MicroStation of that animation sequence, and so that I could play that animation on a surface that I made up for the jumbo screen, I broke up that AVI file into various keyframes or various JPEG frames using what's called Virtual Dub, which is an open source video editing software platform. It's very simple, and it can take AVI or movie files and it can break them up into their individual image sequences. So we're taking image sequences and going into movie format, and we're going from movie format back into image sequences depending on the application using various software platforms. For the batch processing of all the images, when we had images that were taken from AVI files that I had mentioned being broken up using Virtual Dub, we converted those bitmaps into JPEGs, which was a preferred format that MicroStation accepts for animated textures. So Corel Paint Shop Pro is something that we use. However, you could use Illustrator in tandem with Photoshop, or you could use GIMP, which is open source. There's a lot of programs out there that can do this kind of batch processing of imagery to change them to different formats. But it is recommended, if you're doing any kind of animation and you need to do texturing and stuff like that, that you have something like this to be able to stylize your textures as you need to and create your own palettes. This is the animation producer script. This is the director's palette, as it were, the way that you control all the things going on within an animation. So you can turn these on and off. As I made a sequence, for example, of a camera flying a certain path, I could record that and then have the camera switch to another target and record that, and I could turn on and off these different parts of the sequence as I needed them. So I just continually created this larger and larger script as I went through this animation process. And so the letters in red indicate things that have been disabled, and the letters in black indicate things that have been enabled. And I can turn those on and off as I need to record different parts of the animation. So this is quite time consuming, and there's no way to really do this all at once. It's something that develops over time. It usually starts with one camera and one target and maybe one B-spline path that the camera is going to follow. And you just build from there. So over the period of 10 days, which is the time it took for one person to actually accomplish this entire animation and modeling, it developed into quite an extensive sequence. Again, it does take a little time, and it doesn't start all at once. It builds on itself, so don't let that intimidate you. The last step of creating our animation was to bring it into some video editing software. We chose Adobe Premiere Elements. which is a relatively inexpensive editing platform that's very robust and has the capabilities of adding special effects like the lens flares that you'll see in the animation and so forth. I would like to point out, though, that all of the lighting and all of the effects that you do see, other than the lens flares, was actually created solely in the MicroStation environment, as I've outlined in this presentation. So in this particular way, using this software, we can put music to it, sound effects of the jet engines, and other parts of it, cutting it up into the way that we want to see the final rendering. With that, I'd like to thank you for watching this presentation. If you're a beginner to animating, I hope this has gotten you a little excited about using the MicroStation platform, which is quite user-friendly. And if you're an advanced user, I hope you've picked up a few tricks along the way. I'll end this presentation with our final video that we produced for our clients at the Evergreen Wings and Waves Water Park in McMinnville, Oregon. My name is Paul Tice with I-10 Associates. You can visit our website at www.i10assoc.com. And may your future animations be marvelous and your visualizations bring you more business.